Morning.
Good morning, sir.
How are you guys doing?
We are doing
I do
well,
well,
sir.
sir.
You're fine.
We thank God. Thank God.
And your side, sir.
By God's grace, God is in control here. Hello?
Hi, sir.
Yeah, I said by God's grace, I'm also good.
Oh, then we thank God.
Please, I hope you guys watch the video. Watch the video that I sent to you last week.
Yes, sir.
Oh, okay, that's okay. So that's what I'm going to teach again. So if you've already watched the video, then that will be a class to you. Okay. Okay, so let's recap on what we did previously. So previously, we learned something about testing or our hypothesis, making use of these what we call the t-test of independence, where we have a pre or post scenario, and then we apply the t-test. And then we said that the t is giving us the mean divided by the standard deviation over square root of n. And then we said that this is the same thing as the mean over the standard error. Because we said that the standard deviation divided by the square root of n is referred to as the standard error. Okay. And so basically that's what we did. And then we computed our test statistic. And when we realized that it is based on the test statistic that we get our p-value, and then we prove that. Okay. And so that is it for last. So today, what we are going to do is we are going to check, we are going to learn how to test if there's a relationship between two categorical variables. If there's a relationship between two categorical variables. So remember that I said categorical variables is also referred to as qualitative variables. Okay. So that's basically what we are going to learn today. Okay. So let me just pick a plain or whiteboard to start with that. So let's assume you are in a facility, and then we get we have about a number of patients, quite a number of patients, and then you want to know that if the patients coming to your facility, there is a relationship between.
Please, we can see the screen again.
You guys, I'm sharing new screen, so I said I'm going to share a new screen and then use that one to illustrate, right? That's what I said. So that's a plain sheet. Can't you see I'm writing here? Can you see the writings here?
Yes,
Yes, sir.
please.
Yes, sir.
We can see.
Yeah, I said I'm going to illustrate with. Okay. So Pokia Patricia, your hand is up. Yeah.
Please, I have a question.
That's why I called you.
Last weekend, the question you gave us, the last question that you told us to do,
I asked you to go and try.
I have a problem there. About finding the t value. When you get the t value, they gave us another value to compare the two answers. So please, I want you to help. Yes. And they gave us another value 1.0 to compare the two answers. So please, I want you to help me.
Are you the only new person in the room? I told you that we can use the traditional method. When we apply the test statistic, compare the test statistic with the table value. And I showed you the table value, right? And I told you guys that it is based on that we get the p-value, the table value. I read it. So what I have that slides, they have the table value, which you can do your traditional method by comparing the test statistic with that. Okay, so you can see that there's also a p-value there, right? Okay.
Okay.
I hope you saw that thing.
Yes, please.
Yeah, there's also
like it
p-value.
was called, so I thought maybe in exams you can bring that. Is my ask.
Oh no. In the exam, what I can do is I can give you all these. I can give you the p-value. I can give you the alpha, and I can also give you the table value.
Oh, okay.
So you can choose to use whatever that you want to use. If you want to go by the p-value method.
Okay, thank you.
Okay. So now I think we can move on. So what I was saying is, we are assuming that we have there's a facility. You have your patient. There are some patients coming in there, and then you want to know if the patient's gender is related to religion. Is there any relationship between gender and religion? Okay, you want to check that. But I mean, the in charge or the CEO of that facility inform you to check if there is a relationship between gender and the religion, so that they will know what to do. Okay, so for this one, you can see that, let's assume, you can see that for gender, you will get how many possible category can we get for gender? Can someone help us here?
Male or female?
So that means we can get 2.
Yes.
Right? We can get 2. Okay, that's okay. So I can say that gender, let me represent that one with G. Okay, I hope that's okay. G. And then religion. How many possible outcomes can you get?
3.
Okay, you say someone saying 3. Why 3? But you can get more than 3. You can get Christians, Muslims, traditionalists, Hindu, what again? Occultism, a lot of them. But in Ghana here, I think the common ones are 3. Let's stick to that one for this scenario, okay? So that is what you do in research. You have to exhaust all the possible outcomes. And so in research like this, what you can do is, because in Ghana here, most of them are Muslim, Christians, and traditionalists, and probably give room for the others. You group all the others as one, okay? So we can add those, or we can stick to the 3. So let's stick to the 3 for the meantime. So let me put here religion. If I write R, it's representing religion, okay? And then the possible outcomes, or the category that we are having, I'm going to say MU, okay? Which stands for the Muslims, and then Christians, and then I can write the traditionalists here. Then I can write gender. The possible outcomes is female, and then males, okay? So let me differentiate this one. I'm going to give this one a circle. I'm giving this a circle so that you know that this one is the variable itself, and these are the categories, okay? So I can come up with what we call the contingency table. The contingency table will give you the frequencies or the observed values for the respective categories. The contingency table will give you the distribution or the frequencies or the observed values for the respective categories. Okay, so for this case, if I have information, normally all things being equal in real life, for the observe or what you record, you get information about them. Okay, so this one probably the nurse or the in charge told you that those that are male and female, this point, let me put different color. At this point, let me put here E. I mean this point. At this cell, in this cell, it's going to give me the number here, will give me the number of patients that are Muslim and female. Okay, if I'm here, it gives me the number of patients that are Christians and females. If I'm here, it gives me the number of traditional patients that are male. Okay, so I want one to give me, just give me some figures, random. Give me some figures here. Give me some figures.
65.
Again?
65.
I heard the 35 first. Okay. Next here. What about Christians, females?
70. 32.
I heard the 70 first. What about this one?
40.
40. Okay. Now let's come here. The Muslims that are males. How many?
20.
Hey, this one coincidentally, we all said 20. Then that means we have 20 Muslims in the class. Okay. What about Christians?
16.
Males? 16. It's true, when you go to church, you see a lot of females than the males. Okay, when you come here, the traditionalists?
12.
50.
Someone said, is it 12 or 55? Okay.
50.
50. It is true. It is the woman who walks a lot. They walk from one place to the other. So 50 is okay. Okay, so now, this 35 represents Muslims and females, okay? And this 70 represent what? Can someone tell me what this 70 represent?
Christians, females.
Exactly. And so if I want the total, let me write here total. Okay, before I write the total, undo before I write the total. So this table is what we call the 2x3 contingency table. 2x3 contingency table, because I have 2 rows. You see 2 rows here, okay? And I have 3 columns. So that is what we refer to as the 2x3 contingency table. And so in most cases in the exam, I give 2x2. In most cases, it doesn't mean I'm going to give you 2x2. But I can tell you that out of these, I've never given 3x3, 3x2, whatever. Always I give 2x2. But I don't know what will happen in your class. Okay, so now let's move on. So this is the total. Forgive me about my writings. You know, I'm doing my best for you guys. Okay, so now, if I want to know the total number of females, that means I have to sum row. If I go, I hope you know what row is. If I go horizontal like this, that is row. And if I come vertical, that is the column. I hope that's okay. I hope it's okay.
Yes, sir.
Yes,
So
sir.
now I want to know the total number of females. That means that I'll have to go and sum the frequencies. And then, so that means that if I sum the row wise, if I sum this, then that'll give you the total number of females. So that's going to be 35 plus 70 plus 40. I hope it's clear.
Yes, please.
And that
Yes,
will give
sir.
me what?
145.
145.
145. Okay, that's true. Now, if I sum this one, it gives me the total number of males. Okay? And so that is what?
86.
Is what?
86.
That's 86. And then if I come and sum the total columns, it gives me, this one will give me the total number of traditions. That will give, this is what?
90.
And this is what? Total Christian.
86.
And then the
And
total
55.
Muslim.
55.
And so if I sum the column totals, when I say column totals, I mean these ones. Oh, no. Let me choose a different color to circle it. Let me use blue. If I say column total, this is the column total. And if I say row total, these ones are the row total. These ones are the row total. Okay? So you can see if I add the row totals and I add the column totals, I'll get the same answer. And so that is what we refer to as the grand total. So I want you to tell me and I'll write it here. That is where we always write it. This side.
231.
231.
31.
So that implies that the total number of individuals or the sample size for this research is 231.
31.
Okay, so this is what we call the grand total. And so if you're able to do all these things, then this is what we call the contingency table. The contingency table. The contingency table. So from here, then now you can go and compute your the expected, and based on that, you go and compute your chi-square test statistic. And then from there, you get your p-value, and then you draw your conclusion, either accepting or rejecting the null hypothesis. So it doesn't matter. One person too can choose to use the rows as the religion. One person too can draw his table as religion coming here, so that he will get M, C, T, and the other person too can bring the gender here, so that that person too get F, M. So at the end of the day, you get the same thing. You get the same thing. You get the same thing. So 2 by 3, and his will be 3 by 2, but you get the same thing. At the end of the day, I'm going to get the same thing. Okay? You get the same answer. So it doesn't matter. Right. So that is how we come with the contingency table. So let's go back to the slides and then work something out before we may visit this. We may visit this guy. I don't know. We will visit this guy again. So let's try and come back to. Okay, so now let's come back here. Now let's try and see why we have 73, 43, and then that. Or probably let me just try to refresh. Oh, why the whiteboard vanished? Oh. Let me share again. Okay. So in this thing, I can write it in sentence form. I can, instead of, if you are fortunate, and then probably for exam's sake, if you go and then you have a table straightforward like this, then you are lucky. But in real life, you don't get a table. You have to come up with a table. So let's assume that I'm going to put all these figures in sentence and see how best you can come up with a table. And so, as I said, you are in a facility and you want to know if there's a relationship between gender and then religion. So I give you this information that in my facility, I have 231 patients visiting my hospital in a month. 231 patients visited the hospital in a month. And I tell you that out of these 231 patients, 145 are females. And then among these females, I have 35 to be Muslims and then 70 to be Christians. Okay. And then I come back again and tell you that, oh, okay, that's the case. And also I have 86 males. And among these 86, I have 16 of them being Christians and 50 traditionalists. Okay. So you realize that this statement that I gave you, I didn't give you information on this guy, right? I didn't give you information on this guy. And this one too, I didn't give you information on this guy. So if you formulate your contingency table, you realize that this place will be blank. But once you have the total number of females, you can add these two guys, subtract from the total, then you get this thing. I hope it's clear. Again, the statement that I just made, you realize that the information that I gave, I said I have 231 patients coming to the hospital. And then among these 231 patients, 145 are females. Then I move on and say within these female or among these females, I have 35 being Muslims and 70 being Christians. Then I move on and I said that also 86 of these patients among these 231, among them, I also have 16 being Christians and 50 being traditionalists. So help me to know if there's a relationship between gender and religion. So you see, as I said, there wasn't information for the traditionalists, for the female, and there wasn't any information for the Muslims, for the males. Okay, and so what I'm saying is, you can just add the males. I mean, sorry, the Muslims plus the Christians. Then you subtract from the total number of females here, and I'll get the traditionalist value. Okay. Is that clear?
Sir, please, can you come again? I'm confused.
Okay, don't worry. I'll use that one too. I'll use the next slide to elaborate on what I'm saying. Because this one, I don't have this statement in sentence. You find it difficult to recall it. Okay. So basically, that's what I wanted to point out here. Now let's go back to this one. I think I will use this one to illustrate whatever I'm talking about. So let's look at this. So if you look at this one, in a hypothetical study to check if there is effect of fever or malaria. So the first thing is to state your hypothesis. And that one, I'm not going to talk about that one. I expect you to be able to do that one, okay? So if you look at this, they are saying that in a sample of 167, 73 of them, 73 from 85 of the malaria had fever. So what does that mean? Well, can someone tell me what this statement means? In a sample of 167, 73 from 85 of the malaria had fever. So if you want to talk, you raise your hand and I'll call you. Please, hurry up. Winifred Maunyo. Winifred
Yes.
Maunyo.
Sir, please, it means that the total number of people with malaria is 85, and they are saying that only 73 of them has fever.
Okay, but there's also here in a sample of 167.
Yes, the 167 is the total number of all the patients. That's with
Thank you
those
very much.
with
Thank you very
malaria.
much. Thank you very much. Thank you very much. And so in drawing the table, you have fever and non-fever. Okay. Because the information that are giving us fever and non-fever. And so that one is giving us what? You see, that's why I have 73 here. Is that clear? That's why I have 73 here. So please, you can lower your hand. You can lower your hand once. So that is why we have 73 here. Because it's saying that 85, the total number of malaria cases, we have 85. And out of these 85, 73 of them are what? Having fever, malaria at the same time. Okay, now let's move on. Once she has been able to tell us this, we can move on. So the next one is saying that of the non-malaria, only 43 of 82 had fever. So that means that among the non-malaria, the total number of individuals is what? 82. And then only 43 had fever. So that is it. And so you realize that in this example, we are not giving this guy, we are not giving this guy, we are not giving this guy, we don't have this guy. We only have 1, 2, 3, 4. I hope it's clear. I hope it's clear.
Yes, sir.
Yes.
So what you have to do, that is what I was trying to point out earlier. So you don't have this information. So once you have this and that, we know that if I sum 73 and 43, I'll get a total number of fever. Is that not it? Please, is that not the case?
Yeah.
And here, so that means this one I can get my 116. If I sum them, I get my 116. We are done with this guy. But we don't have this number. We don't have this. We don't have that. But we know that this 85 is equal to the total number of malaria patients. And so if I know the fever patients, I can just subtract it from the total and I'll get those who are not fever positive, but malaria positive. I hope it's clear. So the total number of malaria patients is 85. And I know that among these 85, 73 of them are having fever. So if I want to know among these 85, those who are not having fever, I can just subtract this 73 from 85. And so if I subtract 73 from 85, and I'll get what? 82. Sorry, I'll get 12. That's why I have 12 here. I hope it's clear.
Yes, sir.
Yes, sir.
Yes.
Now, the same thing. If I subtract the 43 from 82, and that will give me 39. That is why I have 39 here. I believe it's okay.
Yes, sir.
Okay, so for me to get my 51, I just add 12 plus 39, I get 51. Or complete your table, you are good to go. Okay, then you have to go and compute what we call the expected count and your chi-square test statistic. And so these are the symbols that we are going to use. This is what we call the observed, and this is what we call the expected. The observed are the one that you recorded, the actual data values, the actual data. These ones, these are the observed. So this one, how many observations do you have here?
There are 4.
Four, exactly. So we have 73, 12, 39, 43. These are the observed. Okay. So once I know the observed, I can go and compute the expected for each one. Okay. And this symbol is what we call the chi-square test statistic. This symbol the chi-square test statistic. It's very simple. If you can't write, you can just draw. You can just draw for me. Okay, that is the chi-square test statistic. Now this is the table value that someone asked earlier on. For the traditional method, you compare the test statistic with the table value and then you draw a conclusion. But we are not using the traditional method. Now let's go back to how to compute our. Please mute yourself. Mute yourself. I'm not a host now. I can't mute you. Please. Ebenezer. Okay, so now let's continue. So we have to compute the expected. The expected is giving us the row total multiplied by the column total divided by the grand total. Again, the expected is computed as, you can calculate your expected by multiplying the row total by the column total divided by the grand total. And that will be your expected. And once you know your expected values, you can use that one to compute your chi-square statistic, which is also given as the sum of the observed minus the expected squared divided by the expected. The chi-square statistic is also computed as the sum of the observed minus the expected squared divided by the expected. And then the degree of freedom for this chi-square test, remember for the t-test, we said it's n minus 1. But this one is always the number of rows minus 1 multiplied by the number of columns minus 1. The number of rows minus 1 multiplied by the number of columns minus 1. So as for the now and then the alternative, I'll not talk about that. Now let's try and then compute the expected count. Let's try and compute the expected count. Okay, so I'm going to use the pink color to indicate the observed. These are the observed. These are the observed. These are the observed. Okay. And so now we need to compute the expected counts for these ones. So if I'm in this one, the observed for fever and malaria, if I want to compute the expected count for fever and malaria, what is the row total? It's going to be what? 85. And then what is the column total? That would be 116. I hope you all agree with me.
Yes, sir.
So that means that I'm going to multiply the row total, which is 85, by the column total, which is 116, divided by the grand total. The grand total, as we said, is the sample size. Okay. I hope it's clear. Please,
Yes,
if you
sir.
have any question with this, if you have any question with regards to this, tell me before I move on. Okay, I think there's no
Let's
question.
go.
Okay, so the next one, the observe, the same thing. The expected is what? 85. Sorry, the row total is 85, and then the column is what? 51. So I'll just multiply the row total 85 by 51 divided by the grand total, and that gives me this answer. You can always run it to the nearest whole number. To be on the safer side, just run it to the nearest whole number. And run it to the nearest whole number. Okay. Daniel, ask your question.
Sir, please, that means if you ask us to maybe calculate for one particular thing, meaning you will give us the particular rule that you want us to calculate the expected value from.
I'm not getting your question.
Like from the table,
Yes.
we can see the observed values. The observed values, let's say for taking malaria, for example, the observed values are 2. That is the 73 and then the 12. So that does it mean that if you want us to calculate the expected value for the 73, or if you want us to calculate the expected value, you will specify which of the observed values that want us
No. I'm not going to specify anything. You yourself, as a researcher, I told you that we are computing a test statistic. You are testing the hypothesis. And now you can only test the hypothesis based on the test statistic. And then the test statistic that you are going to use to test your hypothesis is also depending on the expected, not just for one cell, for all the observes. So I don't need to come and tell you to compute the observe for just one cell or this or that.
Okay.
You yourself, you have to know that these things are needed for the test statistics. So you have to compute everything.
Okay.
Yeah, you have to compute it. If you are fortunate and probably, I don't know, probably you are doing any exam and then it's MCQs and then they just say what is expected for malaria and that one, you can just compute only that one and put it there. But if you are testing hypothesis, which we are doing, you need to compute everything, my brother.
Okay. Thank you very much, sir.
No, don't mention. Let's continue. Okay. There is also another hand up. Daniel.
Good morning, sir.
Good morning.
Yes, I just want you to help me with how we came by the observed values. I just lost track of it.
I don't get it. Did you go offline or?
Yes, I was moving from a place to a place, so I didn't get that one really.
Oh, okay. But you already have this video. Did you watch the video?
No, sir.
See you, my brother. At least find time to do these things. You don't wait till the last hour when it's about getting to exam. I just realized that you guys are doing my paper, the first paper.
Yes,
wow.
Please.
So please, you don't have to wait till the last hour, okay?
Thank you.
So the observers were given to us from the statements, from this statement. Then you can put your hand down. So this is where we got the observed from. It's coming from these statements. That in a sample of 167, 73 from 85 of the malaria had fever. Okay. And then the non-malaria, only 43 of 82 had fever. Okay. And so that's why we placed 73 and 43 here. And then we subtracted, because we know the total number of malaria is 85 here. We subtracted the 73 from the 85 and then we had the 12 so that we can get the observed for the malaria and no fever. So we did the same thing by subtracting 43 from the total non-malaria cases, which were given to us in the statement here that only 43 of 82 had fever. Okay, so we ended up subtracting the 43 from the 82 and then we had 39. So from here, I think from here, it's just like what I illustrated with the whiteboard. Okay, Danny, I hope it's clear now.
Yes, please.
Okay, so now let's continue. So now let's try and compute the expected for the 43 here. Now this 43 too is going to give me the row is what? The row total is 82, and then the column total is 116, and that gives me what? 167. I hope it's clear.
Yes, sir.
Okay. And this is 39. The row total is what? Can you help me here?
So the row total is 82 times the column total, which is 51, all divided by the grand total, which is 167, and we are getting 25.
Okay, thank you very much. Thank you very much. So this is how you compute your expected. And so you are done with the next step, but the other step, which is the computation of the chi-square test statistic. Okay, that is what we are going to do next. And that one, the moment you are able to get your expected, it becomes very simple. That means that what you do is you subtract the expected, this guy, the expected, from the observed. Okay, whatever you get, you square it. After you square it, the answer you divide by the expected again. Then you put it somewhere. You come here, you subtract the expected from the observed. Whatever you get to square, after you square it, you divide by the expected again. You come here, you do the same thing. You come here, you do the same thing. At the end of the day, you sum everything, and that will be your chi-square test statistic. Okay, so now let's go back.
Can I take that again, please?
Yeah, I'm going to do it, please.
Okay.
Please, if you want to talk, you raise your hand. Okay, so that is what we are doing here. Let me try and minimize this and see if I can get both. Okay, so now the formula is giving us that. This is the formula. The chi-square test is giving us summation of the observed minus the expected squared. You see there's a square here divided by the expected, meaning that we will have to do this thing one by one before we sum. You see that the sum is affecting everything. You do this, you subtract, you square, you divide by the expected again. Okay, and so the first one, what is the observed for this one? What is the observed for this? What is the observed?
73.
73. And then the expected is what?
Expected is 59.
Okay, now let's try and put it in this formula. So can you tell me how it's going to be?
73 minus 59 all square. All over the 59.
Okay, exactly. Thank you very much. So please mute yourself now, please. So the observed here is 73 minus the 59. Okay, then I square it. That's why I have this one. So let me just zoom in now that you know that it's coming from. Okay, so let me clear everything. Okay, so the observed was 73 here minus 59. Then we square it, divide by the expected again, because that is the formula. So the observed 73 minus the expected 59, we square it, divide by 59 again. Plus, that's why we are saying plus, because we sum everything. Plus the next one, the observed is 12, and its expected is 26. So let's come and put it in the formula. Observed 12, expected 26, the square is there, divided by the expected again. So we are just replacing them. The next one, the observed is 43, and the expected is 57. So what is the observed? 43, expected 57, the square is there, and then you divide by 57 again. So that is how so it depends. So you are going to do this for all the observations. Okay. You do this for all the. So once you are done, then you can now sum everything, and whatever you get is what we refer to as the chi-square test statistics. Please, I want you to try this. If you get the right answer, if you are getting the same thing, please and please and please and please, you type 1 for me. Okay? You type 1 for me. Okay. So what we are doing is we have already made my. Please, you try it there and let's see if you get the same answer. The formula is giving us summation. It is giving us summation of the observed let me put it this way, observe minus the expected squared. Probably they want me to write it all over the expected. This is the formula. And so you just have to go and pick the values, the value that you computed. Okay. So if I come here, the observed is 73 and the expected is 59. So if I'm to put it in this formula, it's very simple. It is going to be the observed 73, the expected 59. Yeah, I don't need to bother myself. Then I square it because that's what the formula is saying. It is saying that I should divide. Okay, then I come and divide. Then the expected again. What is the expected? 59. Okay, I'm done with the first cell. I come to this one, I do the same thing. But don't forget this one is sum. So you add one after the other, one after the other. Then you get your chi-square test statistic. Please, I hope it's clear.
Yes, sir.
So please try it and let me see if you get the same thing. Okay, that's good. People are getting the same answer. That's a plus. Oh, that's a plus. Okay. So now let's try. There's a question hand. Okay, Rose. Rose.
Hello, sir.
Yes.
Sir, please, does the ith row and the jth column simply mean row and column?
Exactly.
Okay, thank you.
Exactly. So if I'm here, that would be the first row, the first column. If I'm here, to be the first row, the second column. If I'm here, the second row, the first column. If I'm here, the second row, the second row. And that's it. Okay. Ooh. Please, I hope everybody's okay so far. So far, so good.
Yes, sir.
Okay, so now let's move on. Now that we know these things, now we are going to draw our decision. Now that we know our our chi-square statistic, we are going to, draw our conclusion. So this one is just from the table value as someone asked earlier on this value. Don't bother yourself with this value too much. Don't bother yourself. These things are coming from the traditional method where I'll go and read it from a table. Okay. So don't bother yourself with that. Now, let me stop sharing. I want to do something before I share. I want to do something. Otherwise, I can't forget where I am. You people go as it. Okay, yeah, I want to. Let me share it. Let me try and see if I can.
Sharing is scary.
The thing, we have the slides already, so where we are not.
I'm making share.
And don't count.
You already have it, so. Okay, so now let's continue. So now, if the p-value, let's say the p-value is equal to 0.00001, and then alpha is equal to 0.05. Are you going to accept or reject it? Just type it for me. Don't say it, just type p, the p-value, p dot value, p dot pv, p 0.00001, and alpha is equal to 0.05. Alpha, or I can say the significance level. Are you going to accept or reject it? You give me reason. You give me reason why you are accepting or rejecting it. Type your reason. You don't say, I'm going to accept, I'm going to reject. Type it. Tell me why you are accepting or why you are rejecting it. Oh, now, no, you are rejecting. You people are rejecting. So give me reason. You don't give me. Okay, so Faizatu. I don't know yours. Okay. Hey, no. Someone is making a wrong judgment here. Okay, that's true. Please come again. Someone is making a wrong judgment here. Okay, what I'm getting so far, so good, but just one person made it. Okay. So now let someone voice it out from us. I want someone to voice it out for us. Obin Kama. Anybody can talk.
So to my understanding, when the p-value is less than the alpha, we reject it. We reject the null hypothesis.
Okay. And so now you can draw your conclusion now that you are tasked to check if fever is related to malaria. So what will be your conclusion? I want you to type. What will be your conclusion? So you see that if you are not able to state your null correctly and your alternative correctly, your conclusion will be, something misleading or whatever. So I want you to just type it for me. Type the conclusion for me. Your conclusion. Now your decision is you've rejected it, fine. Now if you've rejected it, so what is your conclusion? Type. Derek, come again. Derek, are you the statement that we are making here? You are not sure. Your statement is ambiguous. Derek, your statement is ambiguous.
So please, can you bring the statement for us?
No, I will not say it.
No, the screen where the statement is.
Which statement? Oh, it's about fever and malaria. They want to know if fever is related to malaria or fever is related. So you can just draw your conclusion. Okay. William, what you are telling me is not bad. What is right. Okay, so as you guys are saying, that's true. So there's one thing that you should know, that the now will tell that there's no relationship, but the alternative will tell that there's a relationship. So if you've rejected the now, then definitely you should know that there is a relationship between fever and malaria. That's it. You just write it and then I give you your marks. Okay, so now that is it. So the traditional method is there. If you want to compare the traditional method, this is what the lady asked. Please, I want you to try this at your free time. Try your hand on this. This one, I've not given you any p-value. So just compute the test statistic, okay? If you have any question, please talk to me. If not...
Sir, please, are we doing to submit or is just some trial question?
A trial question. Or should I let you submit? If I ask you to submit, then that means you have to scan and then send it to my mail. No, you just try. I don't want you to take you through another stress. You're going to type, scan, it's okay. You just try it, okay?
Thank you.
Thank you, sir.
Is there any question? If not, I'm going to end the class. You said you will not go to church, so.
Sir, please.
He says it's not like that.
We wish to go. We wish to go, but
there's a hand up here.
Then we will go to church.
Bismarck, talk to me.
Please, sir. The last week question that you said we should try it.
Okay.
I tried it and I had a test statistics, which is I had a positive value. But
I told you that you can subtract before from after or after from before. At the end of the day, the only difference will be in the one will be positive and one will be negative, right?
Okay, sir.
Yeah, I told you.
Thank you, sir.
And as I tell you, baby, himself, I found. Hey, Derek, Semachu. William Semachu now, baby, himself, I found. Do one tea. When you are in class, don't do that, right?
Okay,
the next question. Please, if you are done with your question, you lower your hand so that I can call the next person. The next is what? William. Stand up.
Sir. Sir, please, mine is not pertaining to the slides for today. It concerns the exam, since we have barely about 3 or less week to write it. I wanted to know how your questions would be like. Is it going to be objective?
No. This thing I've already informed you. I'm not giving you objective. And I gave you in the previous slide, there was a sample question in there, right?
Yes.
What we did last week. So that should guide you. I'm not going to give you MCQs.
Oh, okay. Okay, sir. Thank you very much.
Yeah. So hopefully next week I'll talk about correlation. And normally the correlation, I don't know if I'm able to do it in just a week, but normally your class, I move faster. Well, the midwifery students, I spent almost 2 hours here, but yours, at most cases, I move faster. So I'm sure that I'll finish the correlation next week. When I'm done with that, probably the following week, I may show you. I may show you a question that will guide you how my questions are. But it doesn't mean that I'm going to show. I said I may. So if I don't do it, nobody will come and question me.
So you are the best. So you know you will do it. You are just the best.
Okay, so the next question, please, if you are done, you lower your hand and then please make your questions brief. Diana.
Please, I want to find out in a certain way you are asked to find, just state the hypothesis. Do you have to calculate the test and then the chi before you calculate your hypothesis, or when the significance level is given, you can just state your hypothesis straight?
Oh, your question is not clear. Are you asking that you're going to just state your hypothesis and then go?
So you see, the first, like last week's slide, there was a question, you gave the significance and then the p-value too was there. So when the significance level is there and the p-value is there, can you just state your hypothesis without calculating for the test?
Oh, my sister.
And all that, because
I've been mentioning that the p-value is depending on the test statistic. So there's no way you can get the p-value without a test statistic, which I proved to the class last week. Is that not the class? Didn't I show you that the test statistic is the guy that made us to get our p-value, class?
Yes, sir, you did.
So then that means that you cannot just go and then do without the test statistic. For this class, I've asked you, even there's a question. That's why I separate the question that you should calculate the test statistic before I ask you to draw your decision and then conclude. Do you get it? But probably if you are fortunate and then I don't know, wherever you find yourself and they give
given already.
Yeah.
Okay. Thank you.
So you need to compute the test statistics just for my course. But remember the questions, it was one after the other. What is the hypothesis? What is the null? What is the degree of freedom? What is the test statistic? Then I come and ask you that, given that the p-value associated with the answer you had in the previous one is this, that. What would be your decision? Then I move on and ask of the the conclusion. Okay? But even if it doesn't follow that, and I go straight forward and ask about your decision, I expect you to compute the test statistic, whatever. You have to compute it. Okay?
Yes, sir.
Yeah. Derek, ask your question before I close. Derek, ask your question. I can stop sharing, right?
Hello. So when do we use the degree of freedom?
The degree of freedom is the guy that helps us to find the critical value. So if you look at this example, let me go back. If you look at this example, the degree of freedom is going to be 1, because the number of rows times the number of columns. And how many rows were there? We have 2 rows and 2 columns. So the degree of freedom is 1 times 1, and that will be 1. So this is the degree of freedom. I hope you can see. Let me just. So you see, I have 1 here, right? Yes. And then the alpha, it was 0.05. That's why I had 3.84. And so you see that I think I wrote it somewhere. I wrote the 3.84. You see? I hope you've seen it.
Yes, but it looks like this one is 841.
And so run it to the nearest number. Run it to the 1 decimal place. So run it to 1 decimal place. What's the answer?
Okay.
3.8.
People, there are certain things. Okay, so you see I have 3.84. Huh?
Okay.
3.84 and 3.841. What's the difference? The same. I hope it's clear.
So my next, yes, sir. So my next question is.
So can I learn?
Okay.
So based on that one, you get this table value, and then for the traditional method, I would have compared the test statistic with this 3.84, and that one, when the test statistics is greater, you reject the null hypothesis. But just that I don't want to teach the two of them at the same time, as I kept on saying. I don't want to, because you may change it. And then if you look at the test statistic that we computed, we had 22 point something. And so if we are to go by the rules and find out where we can compute, where we can identify the number that is closer to 22 as we did last week, you see that the degree of freedom of 1, there is no figure there. If I'm to go, that means I will go beyond. That is the reason why I had 0.0001. Okay. You see that even if I end at this point, it's giving 0.01. I hope you are getting the point.
Yes, sir.
So now ask your next question.
My next question is, if you are giving a table and you have, maybe they give you 2 rows and then 2 and 3 columns, the same way you are going to use to work.
Which one are you going to? Which one?
Like, let's take that you want to calculate for degree of freedom. Will you say that the row -1, because let's take that and then the column -1, and you then multiply that?
I told you that the degree of freedom is equal to row -1 multiplied by the columns of column -1. So if the rows are 10, you just subtract 1 from it. If the columns are 2, subtract 1 for and multiply, and that will be your degree of freedom.
Okay.
Are you answered?
I'm answered, sir.
Okay. So any other? If not, I'm ending the class and meet you guys next week.
I have another question, but maybe
So please, can we get the last week recording?
That one, as I said, that one, I've already told you that my laptop that I had these recordings on the screen, my banner born in the screen, but I used the school's PC. So I'm thinking that they can work on that and send it to you. That one, I didn't have any past video. All these videos are last year's video when I was teaching them on Zoom. Okay, so I have them on in my drive, in my Google Drive. So that's why I'm able to share those ones with you. But that one, I don't have it on my system. So I'll try and see if they work, because normally that one, what they do, they edit it.
Try and get it.
That one, they edit it and take off the questions and whatever. So I'll see if I get that one. I'll send it to you guys. Okay.
We'll be grateful because it tells us a lot.
Last week's one is on the virtual platform. The e-learning kit is there.
I think I have one there.
Last
I'll check.
week's on the class.
It is there, right?
Yes, sir, it's there.
Then go and check that one, because normally I just push the video for last year. So you go there and check them. Then go and check. Once someone is getting it there, go there, the virtual platform, and then platform, and get it. The virtual one. Okay. So see you guys. Hey, Derek, do you still have a question or?
Yes, sir.
Talk.
Yes, sir. Said what we have just finished. Can there be possibility that we will reject the let me say the hypothesis, but maybe it can still be correct?
I don't get your point, though. Is there a possibility that you can reject the hypothesis?
Yes. Like, let's say you have done it and you know that the way you have worked it, actually everything is perfect. But because maybe the values, you look at it and it is not to 1, or let me say it is not up to 0.05, and then they reject it. But can it be that your statement or the research you have done and you calculated, can it be possible that it is correct?
But you are accepting and rejecting based on these things. So if they'll all be lying, they will all be in line. The test statistic and then the p-value, they are all in line. So there's no way the test statistic will mislead you to reject, and then the p-value is telling you to accept. They are all in line, because I told that the test statistic is depending. The p-value always depend on the test statistic. So there's no way one will mislead you. Okay. Okay.
We have yes, sir. So let me just add my last one. My last one is the true hypothesis and the false hypothesis. So can you reject a true hypothesis and it can still be true?
What do you mean by true hypothesis and then the false hypothesis? I don't know.
Okay. So like, let's take that we have calculated the 10 and we have 0.06. Is that one like because the p-value is more than 0.05? Like if that one is true hypothesis, then if it is like you work and it is not up to that.
But I are
so like
I'm not getting your point. This true hypothesis, and then I don't know where you got that from.
Sir.
Can someone help me out?
Sir.
Yes.
Please, I think what he's trying to say is he if I can answer him, like from our previous lessons, I think Master made mention of what's the name? The
type 1 error, type 2 error.
The type 1 error and type 2.
And then margin of error. The margin of error allowed. And that was where I think it's like he stated, is it 0 either plus or minus something figure like that. So to me, I think like what he's saying, yes, in the real situations, you can maybe depending on your situation, you can reject some hypothesis thinking that it is wrong. But in the actual fact, maybe your studies didn't the correct one. So you didn't get the correct results. And that's why you are rejected. And there are also situations that maybe you will accept some, but later on it may appear to be true.
Yeah, I think what you said is right. If he's talking about the type 1, type 2, it's possible. It's possible you can make type 1 error. So that is the reason why, type 1 error is when you reject what? A true null. Right. The null is true, but you've rejected it. But that is the reason why we always want the alpha to be very small. The alpha measures the type 1 error. That's why if we say that it is 0.05, that means that the probability that we are going to make type 1 error is just 5% when we reject a true null. Okay? When we reject a true null. And so that's why we always want that one to be very small. And that is the reason why whenever the p-value, it is less than, or it is less than, it is less than, it is less than that, we are going to reject it. Because the 0.05 is measuring that the probability that the thing is true, but we are saying it is not true. And so if the probability that the thing is true and then we are saying it is not true is 0.05, now we computed it. And then the p-value is telling us that the probability that the thing is not true and then we are saying it is true is 0.0001. That means the thing is not true. That's why we reject it. But that is the rationale behind it. Okay. Okay. My sisters and brothers, please, it's time. The questions, the last person, Mavis, ask your question.
Yeah, the degree of freedom, I'm a bit confused. He said it is the row minus 1 times column minus 1.
Yes.
Is it a summation of the rows or each?
Oh, madam, did I say summation?
On the screen.
I said the number of rows. I didn't say summation. Hey, man, I'm complicating. I say the number of rows minus 1 times the number of columns. I didn't say summation. Hey, see. Why not go for summation? I show now. Okay, Azuma, I hope it's clear.
Yes, sir.
Okay, so I've stopped sharing. I'm going to check if I can get the slides for next week and then the video and share with you right now. So I'm ending the class, and God willing, we'll meet next week. Please take care of yourselves, and God be with us all.
Amen. Bye-bye. Thank you, sir.
Let's